All right. So in this unit, we'll be talking about the atomic nucleus and radioactivity. We've talked about the atom in the previous unit. Now we are going to take a look at the nucleus. Okay. So in this lesson, I'll be talking about radioactivity, the atomic nucleus, and the strong nuclear force in the nucleus. All right. So what is radioactivity? Radioactivity results from radioactive decay, which is a process whereby unstable nuclei is the plural for nucleus, transform and emit radiation. And the radioactivity has existed longer than human race. So you have unstable nuclei, they have an imbalance of neutrons to protons, they are considered radioactive. So what this means is that the nucleus of an atom breaks down, and when it breaks down, because it is unstable, it releases energy, it releases radiations. Okay. So most radiation we encounter is as a result of the natural background radiation that originates in the Earth's surface, in the Earth and space. And most of those radiation we encounter are more intense at higher altitude. Cosmic rays are of two types: high energy particle and high frequency electromagnetic radiation. They affect us indirectly by transforming nitrogen atom in the air to radioactive carbon 14, which ends up in the plants that we consume. Okay? So, quick check, the origins of radioactivity go back to, again, I said it's something that's older than the human race, before humans emerged on Earth. When an atom undergoes radioactive decay, it becomes, again, radioactive decay is just an atom changing. Like it breaks down, and because it breaks down, the composition of its nucleus changes. And if this affects the number of protons, then the element is going to change. Remember, the number of protons determines what element we are dealing with. So if the number of protons changes, then the identity of the atom is going to change. So let's look at type of radiations. So when atoms break down, there are three different types of radiations that can be emitted. One of them is alpha particle. It carries a positive electrical charge. The other one is a beta particle. It carries a negative electrical charge. And the other one is gamma, that carries no charge. So again, you have three types of radiation: alpha, beta, and gamma. So let's look at them closely. Alpha particle, they consist of two protons and two neutrons. Okay, a helium nucleus. Loses energy quickly during interaction, can be stopped easily by a few pieces of paper due to its large mass and double positive charge. The alpha particle that is emitted does not normally penetrate lightweight material such as paper clothing, and then it causes insignificant damage to the surface of a material due to great kinetic energy. It causes significant, not insignificant, it causes significant damage to the surface of a material due to great kinetic energy. It picks up electrons and becomes harmless helium when traveling through air, and is deflected in the presence of a magnetic field or electrical field. Okay. Now, how about beta particles? Beta particle is ejected as an electron from a neutron. So beta particle both has both a small mass and an electrical charge than an alpha particle, and moves faster, loses energy at a slower rate in air, and travels farther before stopping. It can be stopped by several sheets of aluminum foil, and it penetrates fairly deeply into skin. One stop becomes an ordinary electron, is deflected in the opposite direction to an alpha particle in the presence of a magnetic field. Okay. Now gamma. So gamma rays are high frequency electromagnetic radiation. They are emitted when a nucleus is in an excited state, and are more harmful than alpha and beta particle are most penetrating because they have no mass or charge, are pure energy that are pure energy greater per photon than invisible and electroviolet light and X-ray. They are unaffected by magnetic and electric field and therefore interact via direct heat with an atom. So, which of these is the nucleus of a helium atom? That's an alpha particle. Okay. Because a beta particle is a high speed electron, while a gamma is a ray of electromagnetic radiation. Okay. Now, the atomic nucleus and the stronger nuclear force. So, in the nucleus, the strong nuclear force is a very distance sensitive attraction between nucleons. Okay, so a strong force is a force in the nucleus that holds nucleons together. If you guys remember what we learned in the previous unit, nucleons, this is the term that is used to collectively mean neutrons and protons. So nucleons means neutrons and protons together. So the atomic nucleus, again, the presence of neutrons help hold the nucleus together. So remember, protons are positive and they are found in the nucleus. So positive and positive always push against one another, they repel one another. So what causes the protons to be together in the nucleus is the presence of these neutrons that are neutral. Okay. But in a large nuclei, far apart neutrons are less effective in holding a nucleus together. Therefore, we have what we call half-life and transmutation. But we are going to look at this in the next lesson. Okay?